Okay, so you're commanding an Essex-class aircraft carrier in the Pacific in 1944. The ship itself cost around $75 million to build. Call it $1 billion today. That number sounds enormous until you actually break down everything sitting inside that number and realize the hull and the steel were genuinely the cheapest part of the whole operation. A carrier isn't really one asset. It's 3 or 4 completely different, wildly expensive businesses welded together and floating on the same hull, and understanding how those businesses actually worked and how spectacularly they could fail explains almost everything about why the Pacific War turned out the way it did. Compare that carrier directly to the other capital ship option available at the time. An Iowa-class battleship cost roughly $100 million to build and carried a broadly similar crew size, but its offensive power was fixed the day it launched. 16-inch guns that could hit whatever sat within roughly 20 miles of the ship, and nothing beyond that. A carrier costing less to build could strike targets hundreds of miles away, rearm its strike package overnight, and hit an entirely different target the very next morning. On a pure cost basis, the carrier was already the better investment before a single plane ever took off. The battleship was buying raw power, the carrier was buying reach, and reach turned out to be worth more. Beat. The sticker price is only the down payment. An Essex-class carrier displaced over 27,000 tons, carried a crew of roughly 2,600 to 3,400 men depending on how heavily loaded the air group was, and could reach speeds over 30 knots. Genuinely impressive naval engineering for the era. The United States built 24 of them during the war, and the lead ship, USS Essex, went from keel laying to full operational service in under a year and a half. A pace of production that essentially nobody else on Earth could match. But here's the number that actually mattered more than the hull cost. Each Essex-class carrier was designed to operate an air group of around 90 to 100 aircraft. A mix of Hellcat fighters, Helldiver dive bombers, and Avenger torpedo bombers. Those planes weren't included in that $75 million price tag. A single Hellcat cost roughly $35,000 to $40,000 to manufacture. Multiply that across a full air group, and you're looking at another $3 to $4 million just in aircraft. Every single time the carrier needed a fresh set, and carrier aircraft did not have long careers. Between combat losses, deck accidents, and the simple wear of catapult launches and arrested landings dozens of times a day, an air group might need substantial replacement within a single deployment. Beat. The most expensive asset on the ship wasn't the ship. Here's the part that almost never makes it into the tonnage and armor comparisons people love to argue about. The genuinely expensive, genuinely irreplaceable resource on a carrier wasn't the steel. It was the couple hundred men flying off the deck of it. By 1943, a U.S. Navy carrier pilot typically arrived at his squadron with around 500 hours of flight training already behind him. A training pipeline that took the better part of 2 years to complete, running through basic flight school, advanced tactics, and, critically, carrier qualification. The specific terrifying skill of landing a plane on a moving runway roughly the length of 3 football fields. At sea, sometimes at night, sometimes while being shot at. Estimates for the total cost of producing one combat-ready carrier pilot, factoring in fuel, aircraft wear, instructor time, and the washout rate of candidates who didn't make it through, ran somewhere around $75,000 to $100,000 per pilot, multiple times the cost of the plane he'd eventually fly. And that $100,000 figure buys you exactly one trained person. It doesn't buy you the years of accumulated combat judgment that separates a pilot on his first cruise from one who's already survived 3. It doesn't buy you the aircraft mechanics, the flight deck crew who can spot, launch, and recover planes in a tight, practiced rhythm without anyone getting sliced by a propeller, or the radar operators and damage control teams who keep the whole floating operation from sinking the first time something goes wrong. A carrier's real value wasn't the hull. It was an enormous, tightly synchronized human operation that took years to train and could be gutted in an afternoon. To keep that training pipeline running at wartime scale, the U.S. Navy did something almost absurd when you first hear about it. It converted 2 old Great Lakes coal-fired paddle steamers, the USS Wolverine and USS Sable, into dedicated freshwater training carriers, running qualification landings on Lake Michigan, safely out of range of any enemy submarine. Over the course of the war, those 2 unglamorous propeller-driven sidewheelers qualified roughly 17,000 pilots for carrier landings, a mass production training operation running in parallel with the mass production shipyards building the carriers those pilots would eventually fly from. It's easy to picture the war being won by the Essex-class hulls themselves. It was just as much won by 2 repurposed lake steamers nobody remembers, quietly turning out qualified pilots by the thousands. Beat. The revenue model. Striking power, not rent. If a mall's income comes from base rent, percentage rent, and shared maintenance fees layered on top of each other, a carrier's income is something closer to sortie capacity. How many strike missions it can generate per day, and how much damage each of those missions can inflict, converted into the currency that actually decided the war. Sunk enemy tonnage, destroyed enemy aircraft, and captured or defended territory. And the return on that investment, when it worked, was extraordinary. A single Essex-class carrier, properly supplied and escorted, could project air power hundreds of miles from its own position, strike targets no battleship's guns could ever reach, and do it again the next morning. That reach is exactly why the carrier quietly replaced the battleship as the actual center of naval power during the war, even though nobody had fully admitted that shift out loud when the fighting started. Beat. The hidden trap. Everything expensive is standing on the same deck. Here's the structural risk running underneath the entire carrier business model. And it's the exact same shape as the co-tenancy clause buried in a mall lease, a vulnerability that looks fine on a normal day and turns catastrophic the instant one specific thing goes wrong. A carrier concentrates almost every expensive asset it owns onto one deck, at one moment, refueling and rearming simultaneously. Aircraft returning from a strike, freshly fueled and armed for the next sortie, sit parked wingtip to wingtip because deck space is finite. Bombs and torpedoes destined for the next wave sit staged nearby, waiting to be loaded. Aviation fuel lines run throughout the ship, carrying a substance that ignites catastrophically and burns nearly impossible to extinguish once it gets loose. On a normal operating day, this tight choreography is exactly what makes a carrier so devastatingly efficient. Dozens of planes launched and recovered in rapid rhythm, the entire air group cycling through combat sorties on a schedule a land base could never match. But that same efficiency means a single, well-placed bomb hitting the flight deck at the wrong moment doesn't just damage one plane. It can ignite fueled aircraft, cook off staged ordnance, and turn the ship's own air group into the weapon that destroys it, all in the space of a few catastrophic minutes. The ship's greatest efficiency and its single greatest vulnerability were, quite literally, sitting in the exact same place at the exact same time. This is precisely why American and Japanese carrier design philosophies diverge so sharply in a trade-off that echoes the same quality versus quantity tension that shaped tank design on land. British carriers of the same era favored armored flight decks, trading hangar space and aircraft capacity for steel plating that could shrug off a direct hit. American carriers went the opposite direction, favoring wooden flight decks and larger air groups, betting that raw striking power and rapid damage control training would matter more than passive armor. Neither approach eliminated the underlying vulnerability. It just decided which failure mode you'd rather live with: fewer planes but more survivable, or more planes but one bad afternoon away from disaster. Beat. The case study everyone thinks they know, and mostly get slightly wrong. The clearest real-world demonstration of this entire economic model, in both directions at once, is the Battle of Midway in June 1942. And the popular version of the story usually skips the part that actually explains why the battle mattered economically. Start with the American side. USS Yorktown had been badly damaged just weeks earlier at the Battle of Coral Sea, and naval engineers at Pearl Harbor initially estimated it would take roughly 3 months in dry dock to make her seaworthy again. Admiral Chester Nimitz, having just learned through code breaking that a decisive Japanese attack on Midway was imminent, told the repair crews they had 3 days instead. Working around the clock, patching the flight deck, cutting out and replacing entire sections of damaged internal framing, Pearl Harbor's shipyard got Yorktown back to sea in roughly 72 hours, judged good enough for 2 or 3 weeks of combat operations. Her depleted air group was rebuilt on the fly, patched together with pilots and planes borrowed from other squadrons entirely. It was, functionally, an emergency repair job that should have taken months, compressed into 3 days, because losing that specific carrier at that specific moment would have meant facing Japan's 4-carrier strike force with only 2 American flat-tops instead of 3. Now, the Japanese side, and this is where the popular version of the story usually gets the economics backwards. The common telling says Japan lost its veteran pilots at Midway and never recovered. That's not quite what the numbers actually show. Only 36 Japanese pilots died aboard their carriers during the battle itself, with roughly 74 more lost in aerial combat, a real toll, but nowhere near catastrophic enough by itself to explain what came next. The bulk of Japan's Pearl Harbor veteran aircrews actually survived Midway, only to be worn down gradually in the brutal sustained attrition of the Solomon Islands air campaign later that same year, where Japan's inadequate pilot training pipeline finally couldn't keep pace with losses. What Midway actually destroyed in a single afternoon were the 4 fleet carriers themselves: Akagi, Kaga, Soryu, and Hiryu, along with something rarely mentioned in the popular retelling. Over 700 Japanese aircraft mechanics and maintenance technicians, a category of trained specialists the Imperial Japanese Navy had never built a deep bench for in the first place. Losing 4 carriers simultaneously wasn't primarily a pilot problem. It was a hull problem in an economy that had nowhere near the shipbuilding capacity to replace 4 fleet carriers in any time frame that mattered. The United States, meanwhile, had 24 Essex-class carriers either already under construction or about to be, arriving into the fleet at a rate of roughly 1 new carrier every 2 months throughout 1943 and 1944. That's the entire structural comparison in one sentence. America could absorb the loss of a carrier and its air group because the shipyards and the flight schools back home were already running at a pace that treated losses as a manufacturing input to plan around. Japan could not, because a single afternoon at Midway had erased roughly 1/3 of its entire fleet carrier force and the industrial base needed to replace it at any comparable pace simply didn't exist. Beat. What the whole comparison actually reveals. Run the two models side by side, and the picture is almost identical to the tank and submarine economic stories you've seen play out elsewhere in this same war. A carrier, like a Tiger tank or a U-boat, was an extraordinarily capable, extraordinarily concentrated asset, devastating in the hands of a well-trained crew, capable of projecting force no cheaper or simpler weapon could match. But concentrating that much capability, that much training investment, and that much irreplaceable human skill onto a single hull created exactly the same trap every time. The asset was only as valuable as the industrial and training pipeline standing behind it, ready to replace it the moment something went wrong. America won the carrier war for the same reason it won the submarine hunting war and the tank production war. Not by building a single unbeatable ship, but by building an entire assembly line capable of turning out replacement hulls, replacement aircraft, and replacement pilots faster than the other side could remove them from the board. The ship was never really the asset. The pipeline behind the ship was the asset, and the pipeline is the part that doesn't show up in the $75 million price tag, doesn't get photographed at the launching ceremony, and turns out to be the only number that actually decided who won. It's worth sitting with how strange that conclusion actually is. The most feared weapon of the Pacific War, a floating airfield capable of striking targets no other weapon could reach, turns out, on close inspection, to be less like a single powerful machine and more like a single visible node in a much larger, much less glamorous system. Shipyards running on a 2-month production cycle, a pair of converted paddle steamers quietly qualifying pilots on a freshwater lake, and training pipelines back home that never appeared in a single wartime newsreel. The carrier got the photographs. The pipeline behind it won the war. If 4 carriers gone in a single afternoon just rewired how you think about that battle, send this to someone who still thinks Midway was only about pilots. And subscribe. Every week, another system whose real logic was hiding in the numbers the whole time.